So continuing with our second graph, we have y equals to f mod x. Alright, so slightly different now. The previous graph we learned was the modulus on the y value. That's why we flip the x-axis, right, for the negative values, or for the positive values for minus mod fx. But now we have f mod x, and this modulus is applied to our input. As such, our input is now mod fx, no longer just x. And because we have mod x now as our input, it is always positive, which means one thing. If you had a point, right, that was, let's say, -2 and 1, if you have f mod x, this point doesn't necessarily exist anymore, because now at x equals to -2, so let's say we have f mod -2, it will now take the value of f2 instead. Alright, so that is the whole idea of mod x, where your negative x region takes the values of y of the corresponding x region, or positive x region. So what do I mean by this? Alright, so let's say you have 2, 0. Right, in f mod x, -2 will now become f2, which is now equals to 0. As such, you now have the point -2, 0 as well. Similarly, if you're to have, let's say, have 3, 1, then f mod -3 would be f3 equals to 1 as well. And as such, you have -3, 1. Alright, so as you notice, it's basically the reflection of the x-axis, or y-axis. Reflection of positive x graph about y-axis. Of course, you keep the side for the positive x, because you're always we're going to have positive x value. It's just that now the negative x values would take the corresponding y values of the positive x side. So let's say if you had the original graph of x -2. So let me try to go through both points, because -3 and 1 goes through. Okay, yeah. So if this was y equals to fx, y equals to f mod x would simply be, well, from here, we then go through the points. Alright, right here. Alright, now why do you also go to the negative y region? Is because you're only modulusing the x value. That means you're only looking at from 0 to positive infinity. You then reflect that, because, well, f -1 would be equal to f1, but f1 can be negative as well, right? As you can see right here, if f1 is basically -1. Alright, so that is the whole idea of f mod x. Then, of course, the inverse would be true for y equals f minus mod x, where now your input is minus mod x. It is always negative. Alright, actually always positive, plus 0, always 0, plus always negative. Alright, so instead of that, you will now be the other way around, where the positive x region now takes value of the negative x region. Alright, so again, it's still the same thing now, but now is reflect the negative x graph about the y-axis. Alright, so just to give you an example, let me use green. So let's say we use the same graph. Okay, let me just label the y equals to f mod x first. So now we have y equals to f negative mod x. We now have basically looking at the negative side, because now all your inputs are negative. So judging by here, our negative will also become our positive x side. So it's just like that. Alright, so that will be our y equals to f minus mod x, because our positive x values would give us a negative input overall, and we should just take the corresponding y values of the negative x region. Alright, so this is the second equation for our modulus.